This is where I left off in the last one. This was the end of the arithmetic sequence. And now we're going to go on to the geometric. So with all of this, you needed to be able to find the terms, find a specific term, general rule, sum of the first n terms. So we're going to do the same thing now, but now it's going to be a geometric sequence. So a geometric sequence is one in which the ratio of any term to the term that directly precedes it is a constant. So now we're going to be multiplying or dividing. In the arithmetic, you were adding or subtracting. The constant is called the common ratio, r. R can be found by taking any term except the first and dividing it by the preceding, because the first doesn't have anybody before them. Okay, so this one says, list the first 5 terms of a geometric sequence. When the first, if the first one is 4 and the common ratio is 5. So this is going to be 4. Now I'm going to multiply by 5. So I'm going to have 20, 100, 500, 2,500. That would be my first 5 terms. Okay, so now instead of adding, you can tell quickly by looking at it that it's geometric as opposed to arithmetic. Okay, so again, page in the book, and again, everything's the same. This is a sub 1, and now you see it's an r. So as soon as you see r, you know it's a geometric as opposed to an arithmetic. So if I was going to do 31, I'm doing the first 5 terms of 31. The first one's 3. Now multiplying by 2 is 6. Multiplying by 2, multiplying by 2, and that would be the first 5 terms. For 32, 2 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. For 33, 5, 10, 20, 40, 80. So when something is a geometric, it grows, exponentially. It's getting multiplied. Okay, so here's the general formula, okay? A sub n equals a sub 1, r to the n minus 1, okay, where r is the common ratio. This is the first term. This is any term in the sequence, whatever, depending on which one they want you to find, okay? So different formula for the geometric. So this one says find the 12th term, so that's a sub 12, of the geometric sequence whose first term is -4. So I'm going to write the formula down again. So this is a sub n equals a sub 1 r to the n minus 1. So they want us to find a sub 12. A sub 1 is -4, r is 2, and it's going to be raised to the 12 minus 1, okay? It's because they want me to find the 12. So this is -4, and it's 2 to the 11th. You always do this first. You do the 2 to the 11th first, and I got 2,048, and then you multiply by -4, so the answer is -8,192. Okay, you would never multiply 4 times 2, right? You do the 2 to the 11th first, and then you multiply by the coefficient, because the 4 is not raised to that 11th power. Okay, so again, some questions from the book here. The first one, find a sub 5. Okay, so I got 37. They want me to find a sub 5. So the first term, well, let me write the formula down for you again, so you're looking at it. A sub n, a sub 1, r to the n minus 1. So this is 7, and this is going to be 2 to the 5 minus 1. So 7, 2 to the 4th. 2 to the 4th is 16. So my answer is 112. 38. They want us to find a sub 8. So that the first term is 3. R is 4. And this is going to be 8 minus 1. I started to write 7. So this is 3 times 4 to the 7th. So this is 3. 4 to the 7th is 116,384. Then you multiply by 3, 49,152. Okay, last one, 39. A sub 7 is, first one is 64. The common ratio is 1/2, and this is going to be 7 minus 1. So this is 64. This is 1/2 to the 6th. So I did it as a fraction in my calculator. So I got 64 times, this came out to be 1/64, which equals 1. Okay, I changed this to 1/2 to the 6th and to a fraction. But if you didn't, if you just left that as a decimal and multiplied by 64, you'd still get the same answer. It comes out to be 1. And that makes sense because you're dividing. It should be getting smaller. Okay, so now general term, just like we did with the arithmetic, we're just going to plug in this formula. It's a lot easier in the geometric. So a sub n equals a sub 1 r to the n minus 1. So the general term is, this is 2, and you can see that they're being multiplied by 3, so this r is 3, n minus 1. That's it. That's all I had to do for that one. Okay, I didn't have to do anything else. That is the general term. Okay, so for number 43, again, let me write the formula down. A sub n equals a sub 1 r to the n minus 1. So a sub n equals 5, and then r is 5. And so then this would be n minus 1. So now this one, because these are both 5s, we're going to simplify it a little bit more based on what we did in the last section. So this is really a 1, right? Even though we don't write it. So I'm going to do this, 5 to the 1 plus n minus 1. I'm going to add these exponents because I'm multiplying. So the plus 1 and the minus 1 cancel out. So my final answer is 5 to the n. So my answer is a sub n equals 5 to the n. That happens very rarely. It only happens, you'd only do that if these two numbers are the same. So for 44, a sub n equals 3. Now they're being multiplied by 4, so now I don't have to worry about it. That's my answer. Okay, so I don't want you to get tricked up on my math lab because I don't control exactly what the question is going to look like. But if they come out to be the same number, you have to make sure that you simplify it down to the most simplest form. Here, you don't have to worry about anything. Same thing with 45. So a sub n equals 2. Now, to find out what it is, you would just take 1 and divide by 2. Okay, so then it's 1/2 n minus 1. Okay, so if you weren't sure what happened, how did 2 go to 1/2? It got divided by 2, but that means it's multiplied by 1/2. So it's just take the second one and divide it by the first. So you can see for this one, if you wanted to do that, this would be 25 divided by 5. That's why r was 5. For this one, it's 12 divided by 3. That's why it was 4. And here it would be 1 divided by 2. So that's why it was 1/2. So you take the a sub 2 and divide it by a sub 1, that should give you r. Okay, if you're ever not sure of what it is. Sometimes with fractions, you're not sure. Okay, so just like we did in the other one, we're going to sum the first C numbers, and we're just going to take the first number. This is how many numbers they want us to sum. Okay, so that number and that number match, and r is going to be used twice, so that's our formula. So let me write it down here for you again. So it's S sub n equals a sub 1 minus r to the n, all over 1 minus r. Okay, so they want us to do the first 5 terms, so that's S sub 5 equals a sub 1, the first term is 4, 1 minus, the common ratio is 2, raised to the 5 over 1 minus 2. So you do what's in the parentheses first. So I just did in my calculator 1 minus 2 to the 5th, and I got negative 31, because 2 to the 5th is 32. And this is negative 1. So when I divided, I got 124. I multiplied and divided. So you multiply these, and that's negative, and then divide by -1. So the sum of the first 5 terms of that sequence would be 124. Okay, so let me do a couple more for you. Okay, so here's 49. Okay, so they want me to sum the first 6. So it's S sub 6 equals, the first term is 3. So this is going to be 1 minus, the r is 2, and whatever number's here is its exponent, over 1 minus 2. So again, I did 1 minus 2 to the 6th in my calculator and got negative 63. This is negative 1. So this comes out to be negative, divide by negative, it ends up being positive. I got 189. Okay, so 50, they want you to sum the first 7 numbers, so S sub 7. So the first number is 1. 1 minus 3 to the 7th over 1 minus 3. So 1 minus 3 to the 7th is negative 2,186. That 1 in the front doesn't do anything. This is negative 2, and I got 1,093. Okay, for 51, they want me to sum the first 6. First number is negative 3. 1 minus 4 to the 6th. 6, there we go. 1 minus 4. So I got negative 3. In here I got negative 4,095, and I divided by negative 3. Well, I just canceled these out, and I didn't do anything and got negative 4,095. Of course, you could have multiplied and then divided, but noticing that, I thought that was a little bit easier. Okay, so that was the geometric, and hopefully this helped you.